Today we're going to take a look at 7.3 absolute value equations. We are going to use the definition of absolute value when solving our absolute value equation algebraically. This gives us two cases to consider. Case 1, where the expression inside the absolute value symbol is positive or 0, and case 2, where the expression inside the absolute value symbol is negative. So let's take a look at our first example, where the absolute value of x minus 4 is equal to 8. So we will start by using our definition of absolute value. Okay, and remember that's where y is equal to the absolute value of x if x is greater than or equal to 0, and negative x if x is less than 0. So let's apply this to the function that we have. Okay, the argument is x minus 4, so we're going to go x minus 4 if, and then to work out its domain, we take our x minus 4 and make that greater than and equal to 0 and solve for x, and we get x is greater than or equal to 4, and then we'll take the negative version of our argument and then take the x minus 4 and make it less than 0 and solve for x, and we get that x is less than 4. Okay, so case 1 is where we want to take the expression inside the absolute value symbol, make it positive, or 0. So we want to take x minus 4, make it greater than and equal to 0, meaning we want the positive. And then case 2, where we want to take the expression inside the absolute value symbol and look at the negative version of that. So we want where x minus 4 is less than 0, in other words, negative. Okay, so let's take our argument. We want it to have the positive version, so we want to go x minus 4, make that equal to 8, solve for x, and we get that x is equal to 12. We want to take our negative version, so we want to go negative x minus 4 equals 8. We can divide both sides by negative 1, and we would get that x minus 4 is equal to negative 8. Okay, so remember, when we divide both sides by negative number, like negative 1, then what was negative becomes positive, and what was positive becomes negative. Okay, we want to solve for x. We bring the negative 4 over, it becomes positive, and we get that negative 8 plus 4 is negative 4. Okay, we're going to verify our answer. And remember, when you verify, it's always in original equation. Okay, no variation of that. It has to be the original one. Okay? So let's take a look at our first solution, which is where x is equal to 12. And so we can write the original equation. Remember, we want to show that left side is equal to right side. So plug in 12 for x. And then we want to simplify inside the absolute value symbol. 12 minus 4 is 8. And the absolute value of 8 is equal to 8, and so the left side equals the right side. Okay, we want to use x equals negative 4, so once again into the original equation, substitute negative 4. We get absolute value of negative 8, and so the absolute value of negative 8 is 8. And so we are right, left side equals right side. Okay, another way that we can solve for an absolute value function is by graphing. Okay, we're going to use our graphing calculators. And the first thing that you want to do is to enter into your calculator y1, and we're going to enter in the right hand side of the equation and call that y1. So that means the absolute value of x minus 4. Okay, and remember this is your original, absolute value of x minus 4 equals 8 is the original equation. Okay, and then for y2 you're going to enter in where x is equal to 8. Okay, and to find absolute value on your graphing calculator, you want to go to Math, okay, and I think you want to go over to hit your right arrow key to where it says number on the top of your screen, and then you want to choose item 1. Okay, and that will give you the absolute value. Alright, when we have y2 equals 8, that means we have a constant function. Okay, that just means that y will always be 8. Okay, it actually makes it easy to graph this. Okay, your window settings, your x, just do x min is -10. X max is 15. Okay, and I picked 15 because one of our answers for x was 12, so we want to make sure that we can see that. Your y min, make that 0, and your y max, make that 10. Okay, so when you graph y1, you're going to find that you will have a point at 0 and 4. You will find that you will have another point at 8 and 4, and of course your vertex is going to be at 4 and 0, and so you can graph that in like this. Okay. And then y2, alright, so that's y1. And then y2 is your constant function. It will go straight through 8. Okay. Alright, and so what we're looking for are our points of intersection. Okay, so we will have one here and one here, and you're going to find that the one on the right intersects at 12 and 8, and the one on the left intersects at -4 and 8. Okay, and you remember how to find intersection points on your graphing calculator. You want to go to second trace, choose item 5, and then find your points of intersection. Okay, alright, so what are we interested in? We are interested in the x values of our points of intersection. Okay, and so then we can tell that x is equal to 12 and x is equal to -4. So we're going to do example 2, and we're going to take a look at solving a problem using absolute value. So our problem is a computerized process controls the amount of batter used to produce cookies in a factory. If the computer program sets the ideal mass before baking at 55 grams, but allows a tolerance of plus or minus 2.5 grams, solve an absolute value equation for the maximum and minimum mass M of batter for cookies at this factory. Okay, so we're going to start by setting up an equation. Now, a format that you can use is the absolute value of whatever your variable is. So I'm going to say x minus the ideal, and that's equal to the tolerance. Okay, or remember, it doesn't matter which way we subtract numbers inside an absolute value bracket. You can also go ideal minus x equals tolerance. Okay, so for this particular problem, the ideal is your ideal mass of cookie, and our ideal mass of cookie is 55 grams. Our tolerance is plus or minus 2.5 grams. Okay, so if we want to write our equation, we'll use this as our format. So we say the absolute value, and the variable that we're going to use for mass is m, so we're going to go absolute value of m minus 55 is equal to our tolerance, which is 2.5. All right, and remember the meaning of this equation, okay? This means that the distance between m and 55 is 2.5 units. Okay, so what we want to do then is to start by graphing our ideal on the graph. So at 55, okay, and I'm just going to put a line through that. Okay, and remember our distance between m and 55 is going to be 2.5 units. So that means going to the left, I'm going to count off 2.5 units. Okay, so here's 1, 2, and 2.5 is right here. Okay, I'm going to put a bar there. All right, so the distance between here and here is 2.5. And then I'm going to go to the right 2.5 units. So 1, 2.5. Okay. And that's 2.5 units. Okay, so you can see that if we wanted to take a look at the possible masses for our cookies, it can be anywhere in between, right? 52.5 grams and 57.5 grams. So we write a sentence, we say that the minimum mass is 52.5 grams and the maximum mass is 57.5 grams. All right, so let's take a look at this algebraically. We already have our absolute value function, which is m minus 55 equals 2.5. Okay, remember we have two cases. Case 1, where we want to take a look at where m minus 55 is positive, so greater than or equal to 0. And case 2, where m minus 55 is less than 0 or negative. Okay, so we will start by going m minus 55 is equal to 2.5. That should be 2.5. Solve for m, and you're going to get 2.5 plus 55. So m is equal to 57.5. Okay, case 2 is the negative version of that. And that's equal to 2.5. Divide both sides of the equation by -1. That gives us m minus 55 equals negative 2.5. And solve for m. And we get that m is equal to negative 2.5 plus 55. So m is equal to 52.5. And so write a sentence. The maximum mass is 57.5 grams, and the minimum That looks awful. Okay, the minimum mass is 52.5 grams. Done. Example 3, absolute value equation with an extraneous solution. Okay, remember extraneous means that even though it appears as a root, when you solve, when you actually go to verify, it doesn't work. Okay? All right, so let's take a look at case 1. And that's where your argument of your absolute value is greater than or equal to 0. So 2x minus 5 is greater than or equal to 0. And case 2, where our argument, 2x minus 5, is less than 0. Okay, so let's start with case 1. We want to take 2x minus 5 and make it equal to 5 minus 3x. And we want to solve for x. Okay, so I'm going to bring my negative 3x over to the left. It becomes positive. 2x plus 3x is 5x. I'm going to bring the negative 5 over to the left. Sorry, to the right. It becomes positive, and 5 plus 5 is 10. Divide both sides by 5. We get that x equals 2. Okay, case 2 means we want to take our argument and make it negative. Okay, this time I'm not going to divide both sides by negative 1 because it doesn't simplify matters. So I'm just going to distribute my negative through 2x minus 5. That's going to give me negative 2x plus 5. Once again, I'm going to solve for x. I'm going to bring my negative 3x over to the left. It becomes positive. 3x minus 2x is x. I'm going to bring my positive 5 over to the right. It becomes negative. 5 minus 5 is 0. All right, so my two possible solutions are x equals 2 and x equals 0. So let's verify. Remember, always back into original equation. So write out the original equation. That way you won't make any mistakes. We're going to substitute in x equals 2. And simplify the right and the left. Okay, so on the left, 2 times 2 is 4. So we get 4 minus 5. On the right, 5, and then 3 times 2 is 6, so 5 minus 6. All right, the absolute value of 4 minus 5 is negative 1. That's equal to negative 1. And the absolute value of negative 1 is 1, which does not equal negative 1, so the left side does not equal the right side. So x minus 2 we have to reject. Or sorry, x equals 2 we have to reject. Okay, so let's verify where x equals 0 back into original equation. So write that out. Substitute in 0 for x. Simplify inside the radical sign. You have 2 times 0 is 0. 0 minus 5 is negative 5. And on the right we have 5 minus 3 times 0, so 3 times 0 is 0, so 5 minus 0 is 5. Okay, absolute value of negative 5 is 5, and so 5 does equal 5, so the left side equals the right side. Okay, you can also do this on your graphing calculator. Okay, you want to, so if we take a look at our original equation, which is absolute value of 2x minus 5, equals 5 minus 3x, then we are going to make what is on the left-hand side y1. So why don't I just change this to y1? Okay, and everything on the right-hand side as y2. So when you graph that, you can see that y2 only intersects y1 at one point, right? Not two, not like on our last example. Okay. And when you go to check out what your point of intersection is, you will find that it is at 0 and 5. And remember, we are only concerned with the x coordinate when we're solving. And so you can see that x is equal to 0, so that is your solution. Okay. All right, let's take a look at an example where we have no solution. All right, we're taking a look at something a little more simpler than example number 3. What we want to do to start with is to isolate the absolute value. So that means we want to move the positive 12 over to the right. It becomes negative, and so you are going to get negative 3 on the right, and you will have 3x minus 4 on the left. All right, now remember, we can use inspection when we have something as simplified as this to solve. Okay, you notice we don't have a binomial on the right-hand side of the equation, so we can use inspection to determine whether we have a solution or not. Okay, now remember, absolute values always come out as a positive number, so this side is positive. Notice on the left you have a negative. Okay, there is no way that a positive can equal a negative. Okay, and so we say there is no solution, and we can use this symbol for no solution. All right, that ends this segment. So example 5, solve an absolute value equation involving a quadratic expression. So we're going to solve the absolute value of x squared minus 2x, that's your quadratic expression, and that's equal to 1. So we'll take a look at case 1, being x squared minus 2x is greater than and equal to 0, and then case 2, where x squared minus 2x is less than 0. Okay, so on to case 1. We want to take a look at where x squared minus 2x is greater than 0. So that's positive. We're going to make it equal to 1. It's a quadratic, so set the whole thing equal to 0. The 1 becomes negative on the left. And it's not factorable. There are no two factors that will multiply to give me negative 1 and add to give me negative 2, so I'm going to use the quadratic formula. So A is 1, B is negative 2, and C is negative 1. We plug that into the formula. X is equal to negative B, so negative times negative 2, plus and minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 1. I'll divide it by 2 times 1. So we get that negative 2 is positive 2, plus and minus. When we simplify what's inside the radical sign, we get 8 all over 2. All right, we want to simplify the square root of 8. That gives us 2 root 2, divide it by 2, and now we can reduce all of our 2's, but let's factor the 2 out of the numerator. This would be a better way to do it, and we get 1 plus and minus root 2 over 2, and then we can reduce our 2's, and so x is equal to 1 plus and minus root 2. Okay, so that means we have that x is equal to 1 plus the square root of 2, and x is equal to 1 minus the square root of 2. Okay, and then we go to where x squared minus 2x is less than 0, meaning it's negative, so we want the negative part of our value of that, and we make that equal to 1. We're not going to divide both sides by negative 1 because it doesn't make... Oh, we could actually. Let's do that. So we get x squared minus 2x equals negative 1. Bring the negative 1 over to the right or the left, it becomes positive. And this we can factor. There are two factors of positive 1 that will give you negative 2. And so we get x and x. The factors of 1 are 1 and 1. We want them both to be negative. Okay. So negative 1 plus negative 1 is negative 2, and negative 1 times negative 1 is positive 1. And notice we have two equal roots, so we just have to write down one of them. And we get that x is equal to 1. Okay, so now we're going to verify. So we will do that over here. We will start by verifying where x is equal to 1 plus the square root of 2. Remember to plug it into the original equation. So we're going to have 1 plus the square root of 2 squared minus 2 times 1 plus the square root of 2, and that's equal to 1. Okay, when we FOIL 1 plus the root of 2, we are going to get 1 plus 2 root 2 plus 2, and then we're going to distribute the negative 2 over 1 plus root 2, so we get negative 2 minus root 2, and that's equal to 1. Okay, simplify what we can inside the bracket, so positive root 2, well, this should be a 2 by the way, because 2 times the root of 2 is root 2. That cancels with that, and then positive 2 with negative 2. So we're left with 1, and so the absolute value of 1 is equal to 1. Alright, so that works. Let's verify with x is equal to 1 minus the square root of 2. Okay, so into the original equation we're going to get 1 minus root 2 squared minus 2 times 1 minus root 2, absolute value equals 1. Okay, so we're going to FOIL 1 minus root 2 squared. We get 1 minus 2 root 2 plus 2 minus 2 times 1, which is 2, and negative 2 times negative 2 root 2 is positive 2 root 2. We can cancel out our 2 root 2's and our 2's. We are left with the absolute value of 1 is equal to 1, so 1 equals 1. Okay, and then let's do our last one. We verify with x equals 1. Plug it into the original equation, we get absolute value of 1 squared minus 2 times 1, and that's equal to 1. So 1 squared is 1, 2 times 1 is negative 2, negative 2 times 1 is negative 2, and that gives us the absolute value of negative 1 equals 1, so we get 1 equals 1. Okay, so they all work. And so the solutions are x equals 1, x equals 1 plus the square root of 2, and x equals 1 minus the square root of 2. Alright, so we can also show our solution graphically. Alright, so the absolute value of the quadratic function, which is the blue graph, is y1, and the red graph is y equals 1, so that is y2. If we go to look for our x-intercepts, we will have one at negative 0.41 and 1. We will get 1 at 1 and 1. And we will get 1 at 2.41 and 1. Okay, so yes. So what are we concerned with? We're concerned with our x coordinates. So this one, and this one. All right. So we get that x here is equal to negative 0.41. We get that x is equal to 1 here, and we get that x is equal to 2.41 here. Okay, and if we take a look at the solutions that we have in radical form, 1 plus the square root of 2, that's going to give us 2.41. And 1 minus the square root of 2 is going to, these are approximate values, right? That's going to give us about negative 0.41. Okay, so we can see that they agree with the solutions that we have, and so the solutions are about negative 0.41 and 2.41 and one. The end. Example 6 and our last example. Solve an absolute value equation involving a linear and quadratic expression. Okay, so if we take a look at our example, the absolute value of x minus 10, that's our linear part, equals x squared minus 10x, that's the quadratic. We have two cases again. So case 1 is where our argument x minus 10 is greater than and equal to 0. And case 2 is where our argument x minus 10 is less than 0. So let's go to case 1. This is where x minus 10 is positive, so we go x minus 10, that's equal to x squared minus 10x. We have a quadratic expression here, so we want to make everything equal to 0, and so we have x squared minus 11x plus 10, which we can factor, and we will get factors of 10 that will give us 11, 10, and 1, negative 10 and negative 1, and so we get two answers. We get that x equals 10 and x equals 1. Okay, and we go to our second case where x minus 10 is less than 0, so we want the negative version of that, and we make it equal to x squared minus 10x. We're going to distribute the negative, so we get negative x plus 10 equals x squared minus 10x. We have a quadratic, so make everything equal to 0. That will give us x squared minus 9x minus 10, which we can once again factor. We want to make the 10 negative, the 1 positive, so we get that x equals 10 and x equals negative 1. Okay, so we want to verify. We have x equals 10, which is repeated over here, so we just have to verify once for that, then we verify for x equals 1 and x equals negative 1. Alright, so starting with the 10, we want to plug that into the original equation. Alright, so we're going to put in, we'll start with x equals 10. So we'll plug in 10 minus 10, and 10 squared minus 10 times 10. Well, 10 minus 10 is 0. 10 squared is 100 minus 10 times 10, which is 100. So we get the absolute value of 0 is 0, and 100 minus 100 is 0, so left side equals right side. Okay, next we will do x equals 1 into the original equation, so we will get 1 minus 10 equals 1 squared minus 10 times 1. And so we get the absolute value of negative 9 equals 1 minus 10. Absolute value of negative 9 is 9, and that does not equal negative 10, so left side does not equal right side, so x equals 1 is not a possible answer. And then we go to x equals negative 1. Plug that into the original equation, so negative 1 minus 10 equals negative 1 squared minus 10 times negative 1. And so in the bracket we get, in the absolute value bracket, we get negative 1 minus 10, which is negative 11. And that's equal to negative 1 squared, which is 1, and negative 10 times negative 1 is positive 10. Absolute value of negative 11 is 11, and 1 plus 10 is 11, so we get that the left side is equal to the right side, so that one works. Okay, so our solutions are x equals 10 and x equals negative 1. And we have finished this section.